Step away from the podium.
Is your mic on?
Okay, don't all rush in at once. Is anybody out there live streaming?
I only mention that because I know what it's like whenever you're on the other end. You're like, I see somebody there.
That's a good one, yeah. So if I slip and fall here in this,
All right. I guess they can hear me as well. I figured I'll put this on. So it's good? Okay.
okay, ready to go? Let's kick it off. All right, so the first thing you might notice here, everybody that showed up, is that we changed the title. My friend here, Ishu, decided to put a little bit different title on it. It's basically the same material, so don't get too confused about that stuff.
I figure I'll make it a little catchy. So
Go ahead and hit the next one. So today we're going to talk a little bit about some architectural work we've been doing for the last 4.5 years here at Red Hat. Started out as a really small project. I was involved from the beginning. Ishu has been involved with the telco and the edge. We have another talk later on Saturday, I believe, in the morning that covers some of the edge use cases. And what we're going to cover here today is a little bit of the background, and I'll throw a few stories in there about some stuff that happened in the beginning to get where we're at now, point you to a few of the resources, and then I'm going to hand it off to Ishu, and he will take us through the actual specific examples that involve very large telco deployments and customers that have been doing some fun stuff. All the stuff you see today you can find online. Nothing's secret. Nothing's been hidden. We have a Red Hat Portfolio Architecture Center where all this stuff is up for the public. So feel free. Go ahead. So when this all started, and you all can think in app dev or in actual building of buildings, architectures are meant to be really easy to understand, very precise. How many people here are developers or have done development? So you've often been sitting there trying to design something, and you're putting together the architectural documents and the functional designs. And you think this is all perfectly clear. So when I hand this off to my team, it's going to come back perfect, right? Exactly what I wanted to build. I mean, come on, we've drawn the lines, the dimensions. We've shown you exactly how many inches things are supposed to be. How many people have been in houses that have been messed up because somebody didn't follow the design? Yeah, it's really silly, but it shouldn't happen. You hit the next one. But these designs turn into this. And I know this is really extreme and this is really rare. This doesn't happen that often, but somebody physically did that. You know what I mean? That's just that we think that's stunning, but it's not. And so we stepped back and thought, how can we get together here and put something together that's a little bit more higher level? I'm not interested in going into collecting a bunch of TOGAF, certification, very complex things where you have to have done a lot of classwork and research yourself to even understand what I've drawn up. We want to do something where we collect people that have done it before so you can also do the same thing. So you can build beautiful things, or at least understand how they're putting things together. We're all smart enough when we get out into our customers or into our own environments to put the pieces together. But where do you put the pieces? How do you tie them together so that they scale? That's kind of the idea. So what we did was we decided to take actual customer implementations and go look at them. And one of the things you often run into in organizations when you're trying to share this kind of information is that it's proprietary or it's not an actual public reference. And if you're waiting for public references, you're going to wait a long time. And they also tend to go away rather quickly because somebody decides to be a public reference so they can get it to be a part of a keynote at Red Hat Summit, for example. And then within 6 months, they decide, I don't want to be a public reference anymore. And you have to pull that offline. So that doesn't have a lot of value to share that with you. So what if we anonymize this stuff a little bit? I do the research. I dig into anything I could find, whether it's public or not, and then we share it in a generic fashion. So we up-level 3 different research projects to an architecture that we can then design. So what's common between those? Because just digesting a single architecture and reproducing that for you doesn't do you a lot of good when you're dealing with different choices you've made in the past and different like restrictions in your own architectural environments. So we thought if we did it at scale and brought it up to a generic level, that would be more interesting, right? So let the smart people figure out how to tie these 2 services together, but they do have to have these in these locations to make it work. So what we did is we did the research and we came up with a way of doing an architectural diagram. Initially started with Draw.io, if anybody knows what that is. That became diagram.net. Basically, that's a SAS diagram tooling in a browser. Don't care what you're using, anybody can use it. And then we put our own configuration on top of it and then host it. So we suck in the base project from them, and then we diagram across it with our own icons, our own colors, our own lines, templates, so things lock and click and all that kind of stuff. And we kept it very simple, very descriptive, very easy to understand, I hope. That's kind of the idea. And that's the feedback we've been looking for through those 4 years as we've done this. We're now up to 20, anything been released since I left? 30 plus, including the ones in progress. When I left last month, there was 25 or 26 that were published, which means they're completed. And they include, screensaver, they include the diagrams, they include enablement presentations. So we do a public one and then an internal private one that includes exact links to the research document that I used for customers or whatever that didn't have public references. So that's the only piece you won't see. There's presentation videos on how to look at the diagrams of what we're talking about and what these things mean. And everything you find in those presentations is a direct link to the tooling. So if you click on them, they will open up in the tooling with the diagram you're looking at. So any of our internal solution architects can then adjust the titles or change it into something specific for a customer if you want to talk about them. And we've also done publications. A lot of it's ended up on DZone or on Enable Architect, one of the Red Hat blogs that are out there, kind of walking through the various phases of the stuff we found. A really great example was one of the first integration ones I did. I wasn't really sure whether I was on the right track until I wrote the articles. So I stepped back and kind of walked people through it. And the first 4 I published, they had 40,000 page views inside of a month. I think there was, by the time I got done, there was 240,000 page views on that series. That's crazy. So you know people are really, really desperate for just a generic look at how to make this stuff work because it's complex. You know, the stuff we're doing in the cloud and the cloud native world is not easy. And it's not easy because you're having to tackle all different kinds of components. Next one. There we go. So this is zooming in a little bit into what we decided to do with the architectural diagrams. This was really a lot of conversations between us and people out in the field that how can I digest this and digest this with people that are architects at customers. And I also talked to several of my good friends that are out there working at pretty high level architectural positions in some of these organizations. One is in an airport in the Netherlands. He he made a comment, for example, can you put a little bit more details in the logical diagram because my architects aren't smart enough to figure out how to map what you're calling this into our organization. So a little bit of a description would help. These kind of feedbacks makes this stuff more consumable for everybody. And that's what you're looking for. I don't want to build stuff that nobody uses. I don't think you want to see shit that you can't understand. So we're trying to find a way that we can all sort this out. So we chose to use the kind of diagrams you're looking at. And if you look at these things here, you'll see there's different blocks and stuff and different groupings of components. That's the logical one. Not very hard to digest, very easy to see how you got to put the different components together. And this is an example of a use case that then dives down inside and looks at what does it look like when you tie it all together? And maybe it's put into clouds, or maybe it's put into data centers, or where do I group my services and that kind of stuff. And this is very specific to what we found inside of various customer research projects that we dug into and real implementations. Then if you want to zoom down and talk about this specific one, you can go down into an individual component and then zoom in to something a little bit if you want to. Next. And with that, I'll be passing it off to an example of telco stuff, and we'll walk you through a few of these with Ishu.
Thanks, Rick. So before I kind of give examples for telco in the same format that Eric described, let me ask, how many people have a telco background here? Yeah, perfect. That's what I'm expecting. So I'll just give a brief history of what's going on in the telco world, and specifically focused on service provider for cell service, right? So we're talking about Verizon's, AT&T's, T-Mobile, who provide service behind your cell phone. So that's why the title, what's powering your network. And brief history is, they have very storied history. They've been providing telecommunication services since 90s, since the cell phones came about. They've been providing services, monetizing these services, offering you, text messaging and email, et cetera. And their model was, every couple of years, they upgrade their network. So, from 2G to 3G, 3G to LTE, 4G, and now 5G. And then they manage these networks, throughout this. And it's pretty expensive. I mean, in 2021, I think Verizon spent about $18 billion a year for the CapEx, for the capital expenditure, right? Overall, I think AT&T is about $20 billion. So it's pretty expensive each year for them to buy these equipment. These are, equipment from Alcatel, Lucent, Ericsson, these big boxes that do line speed transfers. And you have, a firewall setting for VPN, really expensive stuff. And then even to, manage these networks, so their operating expenses are pretty expensive, it's very substantial as well. So we are talking about, in 2020, I think about $1 trillion, that's how the network providers spent all over the world. So it's almost, 65% of their expenditure is on operating expenses. So the CapEx and OpEx for them is really big deal. And what has happened meanwhile is that, smartphone came about, 15 years ago. And a lot of the services that are being offered on these phones, like, streaming services, Netflix, or, Instagram, or messaging services, WhatsApp, that's where actually all the over-the-air applications have been monetizing, right? So these companies become trillion-dollar companies, while the network operators are still doing a lot of expenses, but they have not seen the return. They're just providing of plumbing or dumb pipes, where other players come in and lay their application on top and get the valued services. So network, when service providers realize this, they need to change something. They first of all need to reduce their CapEx and OpEx. They cannot afford to build data centers and then put up equipment that probably will go obsolete or doesn't allow them to offer new services as fast as their cloud peers do. So they realize these changes, and they have been transforming this bit by bit. First, it was moving, instead of these big boxes, moving out to the off-the-shelf hardware, and then doing virtual machines running on top each of these functions. So virtual network functions, right? And that wasn't fast enough. It still was taking them a long time to manage these VMs, and they cannot deploy it as flexibly. So for 5G, a lot of transition where it's going is in the area of containerizing these functions. And that's where we're going to talk about some of these examples for 5G, where service providers are realizing they need their functions, and they also need to use hyperscalers like AWS, Azure, et cetera's infrastructure to run up these services. They cannot afford to build their data centers everywhere. It runs hundreds of millions of dollars to put it together, another tens of millions of dollars to upkeep. And then when they have to change, for example, if they have customers in Boston, and all of a sudden the demand is coming up in, say, New York, they will have to put the same equipment. So they realize that they need to able to move faster. They need to able to move to a shared infrastructure like hyperscalers. So that is where a lot of work is going for 5G. They want flexibility. They want disaggregation of hardware and software, and then automation to be able to scale and move faster. So here is an example in the same diagram type that Eric talked about. So this is kind of, we call a very high-level architecture diagram, where we're going to be talking about 3 use cases for telco. One is the 5G core. which this architecture is going to talk about. Next one is going to be their operational and business support systems. And the third one is going to be the radio access network. So we'll just skim through these just to get you a flavor of what's happening here. You can see that what they're doing is they're trying to use the hyperscalers for infrastructure services. They are using container platform. This could be on-premise, running on hyperscalers, but that's where their 5G core functions are running, right? And we'll look at some of these. And then underneath all this, they have a common management and orchestration layer that allows them to do a lot of things that, like telemetry, what the status of different, containers or applications is, the cluster management, security and policy management, and they have really big regulatory requirements. So they need to have good policy and security management. So that is where they're headed for 5G core. And this is kind of a little bit more detailed view of, and I know it's kind of hard to see, but the goal here is that they are looking at data coming in from radio access networks into the user plane function. From there, it's going to access and mobility management functions and session management. These are, control plane functions where once the session is established, they need to be able to handle it as the user moves from one cell tower to the other. And then you have all the other main functions to sustain a 5G core. Then there are, supplementary functions. So these are, how would you do network exposure, or you would do, different kind of applications to provide, 5G core services. At the bottom, these are infrastructure services. So this, if example, would be AWS. So you have, their identity management service, their, network firewall and routing, all of these being used. That's all reported to hyperscalers. And then on the left, you have, management orchestration layer where, you have a lot of telemetry and orchestration happening. Again, the container platform is a key thing here. So Kubernetes is powering this. Their, hyperscaler infrastructure or on their own on-premise. So it provides them a common platform. They can run applications wherever it needs to be. If they need to move from Boston to New York to Phoenix, they can very easily reconfigure and run the applications wherever the customers or the demand is. I know we are really short on time, so I will quickly move to the next example. So this is the operational business support system. So what's happening in this area is this is what the network operators use to run their operations. So if I'm running a 5G network, how do we run it efficiently, right? Making sure that all the applications are providing the service to the SLA level that are committed, right? So the calls are not dropping, or business support functions like billing. You get your bill at the end of the month, or if you're prepaid, then you are paying for this. And every time you make a call, it wants to make sure that you actually have enough balance in your account before you can make the call. So all of these things are happening behind the scene for telco providers, and OSS, BSS are the systems, and they have been, again, black boxes, right? Providing these services. If they want to spin up a new service quickly, it was very hard for them to do it. So they figured they need to modernize it using the same approach. Disaggregate, remove, hardware and software. Hardware is running on off-the-shelf, components. Software are these different network functions, or in this case, business functions running in virtual machines, or in this case, containers. And you can move them around as needed. So it gives them agility, gives them, flexibility to, spin up new services as the new use cases like IoT or Edge that Chris was talking about come about. So it gives them, same capabilities as their cloud peers have. This is a, view of what the each of this. So at the underlying, you see common theme infrastructure services provided by hyperscalers. On the left, you have central management. This is a piece that's changed for OSS BSS. So you have, platform components that we talked about. We have core functions like fault management, accounting, performance management, and then you have value-added services like if they want to do AI/ML kind of modeling to see where the things are failing. If there is in particular location, there are a lot of calls being dropped. They can do some model analysis to see what's going on, right? So they can do a lot of these things using value-added services, like service assurance, right? If I'm committed to provide you, this kind of bandwidth in this time frame, am I able to meet that? And then finally, we will go to the last one, which is, radio access networks. The radio access network is a piece when you, make a phone call from your cell phone. This is, you dial the number or whatever, right? And it connects to the radio access tower, right? So that is the radio access network piece for the network service provider. So this is, again, very expensive for them to maintain. We are talking about tens of thousands of towers and equipment at these locations. So anything they can do to modernize and reduce the cost will help them a long way. At the same time, 5G, they want to offer new services. They want to be able to offer you, VPN capabilities for selected customers. They want to be offer guaranteed bandwidth for selected enterprise customers. So they can do all this, but they have to quickly spin up services, right? Same thing, agility, and how they are doing it, again, disaggregating, the radio functions, baseband unit, and breaking it up into, 3 different pieces. Radio unit, cell site, distributed unit, and this is the region. They have, some kind of central unit, and the core data center is where we have the 5G functionality running. Same idea, we have, common layer of management. I will go to the last slide, which talks about, breakdown of same idea. Have shared management cluster services. You have, the edge data center, cell sites, and then core data center running the core capabilities here. There are some other components you didn't see before, like image registry or image repository. This is to make sure that if they're disconnected from the central site, for some reason, the cell tower and region can still function, in a disconnected mode. So a lot of these self-sustained capabilities are built in.
And to be really honest, Ishu put a lot of work in these. These are really complex environments. This is as busy as it's going to get in our architectures, by far.
And I'm not even a telco expert. So a lot of work behind this from our telco architects and team who actually work with Verizon's and AT&T's to understand what their capabilities are, how they are breaking it down, and then capturing it into these diagrams. And then there's a lot more, right? So there is actually, if I, and the slides are available for download, you will see actually how the interaction is happening with this component, right? So there's more detail behind these high-level architecture diagrams. So you can take a look. I'm not going to go into this. But the key idea here is that how telco service providers are trying to survive or actually thrive for 5G is by disaggregating, by leveraging a lot of the cloud-native capabilities, by using the shared infrastructure offered by hyperscalers, and then being able to offer services much faster and much cheaper than what they have been able to do in the past. So I'll stop here.
Okay, and before we go to questions really quickly, 2 things I wanted to mention. So you can get all the details behind this and more at the Red Hat Portfolio Architecture Center. If you look for that, there should be links at the end of this thing with that in there. And I also did earlier this year a talk at DevOps in the UK in London, where I covered the tooling live on stage. So how to use it and to draw and to do all, it's all on YouTube. You can find all that. If you can't find it, just reach out to me on LinkedIn, Twitter, whatever. You'll find me, and I will happily share a pointer to those things. I've also blogged about it, so if you Google around a little bit, you should be able to find it. Are there any questions? And before you ask them, let me give you the mic. I can't tell whether you're smiling or whether you're...
Hey, Liz.
When you do present one of these architectures to a customer or a solution architect, what does the conversation go like?
Great question. So traditionally, I think, and depends on, right, who you're talking to, right? In some cases, these could be the network architect, right? For them, the conversation is, I have these kind of capabilities. I have this kind of expertise that I can configure Ericsson, equipment, and that requires a lot of certification. How can I have equivalent capabilities in these, container network functions, right? So there is some learning involved from their perspective. So that is their concern is, how do I, create same capabilities with my certification, right? So for them, they need to be trained on some of these, more cloud native, way of doing things. Other conversation is more on the IT architects. For them, it's great because I didn't know these black boxes. They were there. I have my enterprise network that I've been able to roll out and update very quickly. And now this allows me to bring in these, network-centric components into the IT fold and handle it same way. So I think depending on who you're talking to, audience, the conversation is a little bit different, but I think they all see that that's the direction they need to go. Thanks.
And each one of the architectures includes an asset that walks you through what it is to talk to one of these stories. So we try to give you a little heads up on that.
I've heard of some telco providers wanting to run Kubernetes clusters on the 5G cell towers themselves. And I was just wondering if you're familiar with that and what kind of workloads they're trying to run there.
Yeah, no, great question. So yes, that is true. So what they have been trying to do is same thing, right? Extending these capabilities all the way to the radio access towers, right? And for them, they have a little bit need. So they're not like generally in enterprise on a cloud, you're running 3-node clusters or multiple node clusters. For them, they want to be able to run single node clusters, right? Or they just want, and that's exactly the capabilities that we from Red Hat perspective, right? We started offering single node OpenShift based on these requirements from telco providers because they needed these capabilities that nobody else was asking for, right? So they needed to be able to function in an isolated environment. And for them, the use case is that, I have, for example, if I'm a location close to a stadium, right? There's a game on Sunday. I need to able to serve, 100,000 customers for 3 hours, and after that, the demand goes away till the next game comes up 2 weeks later, right? So they like the idea of Kubernetes being able to offer them these, peaks and valleys of demand, and they demanded that it's not the standard, data center Kubernetes, but specific features just tailored for their edge needs. So yes, seeing that. Thanks.
1 minute left, so I don't really think there's time for any public questions. But if you have any questions, you'll find me and Ishu walking around here. And again, we talk on Saturday.
And yeah, like Eric is talking about Saturday, we have another session that's focused on edge use cases. This was telco, and I think that's a 50-minute session. So we'll be able to spend a lot more time on different edge use cases of what we are seeing with the customers, what they're doing on edge.
See you there.
All right, great. Thank you all.